Okay, so here we have two wires. So the y1 had a drift speed which is raises linearly from 0 at circumference r, small r is equal to big R, to a v0 at the center, to r is equal to 0. So basically we can see that the drift speed is not constant in y1, is changing, and that function is given in terms of vd as a function of r, v initial, the v0, open the bracket 1 minus small r divided capital R. But however, in the wire 2 it's constant. We have to find I1 divided by I2. What will be the numbers? Okay, the answer. Okay, so how can we solve it? First of all, we know that in y1 the drift speed is not constant. It's actually is varying depending on the radius. Okay, so that means what we can do, we can take a small ring. Okay, small ring in the y1. So that small ring, it's a very small ring. Okay, so the thickness of this ring will be dr. Okay, and it's placed at a certain r. Okay, this is r. And that one makes a current which is very small current, which I call it di1. Okay, a general formula for the current in the wire will be nq area drift speed. Okay, now we want to find what is the current, very small current, dy. So di1 is equal nq. Now what will be the area of this small ring? First of all, you have to measure the length of this ring, and then you multiply to a thickness, right? So that means it will be 2 pi r dr. That gives you the area. Okay, so let's plug it directly there. 2 pi r dr. Okay, now our drift speed is changing, right? So let's plug it, that one there, where we have v0 1 minus small r divided by capital R. Okay, now then we can say that di1 is equal, let's rearrange certain things. We have n q 2 pi v0, then let's multiply r to the inside of the bracket, so we'll get r minus r squared divided by capital R, and then dr. Okay, then we can integrate both sides. The limits will be from 0 to capital R. Okay, so we got current 1 is equal n q pi v0, so that will give us r squared over 2 minus r cubed over 3r. The limits from 0 to r. Then we got 1 is equal 2nq pi v initial. So if you try to plug the numbers directly, you should get that r squared divided by 2 minus, this will be r cubed, then 1 r will cancel out, so it means r squared divided by 3. Okay, so the final answer that is 3 is 2 6 1, so that means I got nq pi v initial r squared divided by this one 6 will be divided by 2, will give it 3. Okay, now we found the current one, where we get which was equal to NQ pi V0 R squared divided by 3. Okay, now let's find what will be the for the current 2. Now we know that the velocity, drift velocity, is constant across the wire in the wire 2. Okay, so in that case, what we have to do now, the current 2 is equal, let's write down NQ. Now the area, what will be the area of this thing? Okay, what is the area? So the area of this one will be pi r squared. Okay, that means NQ area is pi r squared. Then drift velocity was equal, so v drift velocity was equal to certain function, certain constant, and v0, right? So we can put here v. Okay. Then what else? Okay, so finally we have to find I1 divided by I2, correct? So the I1 divided by I2, I1 was NQ pi V initial R squared over 3 multiplied to the NQ R squared FV0. Okay, so V0, this NQ, sorry for that here, pi, the pi will also cancel. Then finally I will get 1 over 3f. Okay, that means I can get 3f multiplied current 1 is equal to current 2. Now this one f is given, I think it was 0.47, so you just have to multiply to 0.47. Okay, that's it.